in brief, that science is in essence no different from the other activities that humans do. It's a kind of art. It's something that we all do as a community. Whether somebody's good at writing prose or poetry, or is a fine artist that can paint a capturing canvas, or whether he's a mathematician writing down equations, Eddington's view was that these things all in some way related and that they're all representative of human activity. So I'd like this evening to go through a series of pictures, most of which are taken from my upcoming book, which, by the way, you don't need to buy because it's not even printed yet. So don't take this as any kind of promotional thing. But the pictures I will show you and the argument I will present is given in detail in the book, which is due out this summer. Now, when I was a graduate student at Cambridge, reading about things like this was not something you were supposed to do. You were supposed to be flogging your brains out in your apartment, remembering equations, or anyway, remembering how to solve them, and you were not supposed to read 200 or 300-page books about philosophy. I did read those books by Eddington, and they always stuck with me. So as I got towards the later stages of my life, I came back to it, and what I'm going to present to you today is basically my agreement with Eddington and the suggestion that he was right all along. At the time, he was very heavily criticized by both philosophers and physicists. The physicists thought he was selling out to the philosophers. The philosophers thought that what he was talking about was something incomprehensible, like a new form of philosophy. And being a very jealous genre, they didn't appreciate that. In later years, though, the last few years in particular, advances in quantum mechanics have been very counter-intuitional, and recent discoveries in astronomy are very opposed to what we would normally think of as straightforward reasoning. I therefore think it's quite acceptable to revisit what you might call Eddington's philosophy, and so I'm going to try and describe it to you. The aim of it is, as I say, that we shouldn't understand science as being separate from the arts, but both parts of some bigger, at any rate, thing. So we have here the starting point with Einstein and Eddington. Eddington was a brilliant mathematician. He started off as an astronomer, an observational astronomer, and his views about everything was quite strongly influenced by the fact that he belonged to the Quakers. He went to the Friends Meeting House on a regular basis, and there may be some people here this evening who are familiar with that approach to life. I don't want to call it a religion, because it really isn't. It's more in the manner of Buddhism. It's a way of conducting your own personal affairs in a spiritual way. My grandma was a Quaker, and that's not the reason I'm interested in Eddington, but if I was obliged to pick any religion, like you often are on forms given out by the government, and you have to cross off one box, then it seems to me quite reasonable to scratch out Quakerism. Of course, the main tenets of that approach to life are non-violence and the absence of authoritarianism. Quaker meetings are not normally held by one person who has some kind of higher status than the other ones in the group. It's a group collective effort. And you will find that Eddington's attitude towards science reflects that attitude. Now, when I did my book, the publisher said to me, as an author that I've done lots of books with these guys, they said, well, you know, this is not really science, is it? This is more like philosophy. Can't you at least put something in it that looks like science? So this is an attempt to do that. It's a diagram with 2 points labelled A and B. And I'm not being totally facetious because I will get to the point in a while. In physics, about the most elementary question that you can ask is, how does something which starts at A get to B? Whether it's a light ray or a particle or a planet or anything else, you would like to come up with some simple explanation for why it goes from there to there. It could, in principle, go an infinite number of ways, couldn't it? Illustrated by these other curves. Euler, Lagrange, and Fermat looked at this principle. In the form of Fermat's principle, every physics student knows what the answer is. A photon, a particle of light, will travel on the straightest line. The same thing applies to mechanics. If you talk about local particles, then they travel on straight lines. Even on the surface of the Earth, for example, on the plane trip I just came along, if I could start in Victoria, British Columbia at some point, and I end up in Louisville at some other point, of course I can't go in a straight line, because the Earth is not flat. I have to go in a curve, a great circle or part of it, but nevertheless it's still the shortest way to get from A to B. And airlines know that very well. They don't want you wasting gasoline going off everywhere else, okay? So there's always a way that you can define the quickest way or the shortest route from A to B, and all these other possibilities are there as theoretical things only. The real world does not follow them. Why exactly, I'll come back to later, but we should all be familiar with the fact that when things are left to themselves, they will in general go along a straight line. Now, in physics, this is the basis of a lot of mechanics, because in the book I was talking more about the ideas of cosmology and the history of physics. I thought that, well, you know, what happens in science, if Eddington is correct, should also happen in the real world. This should not just be some abstract problem about how you go from A to B with all these other possibilities. How does the physics world choose out the path from A to B? Well, it does it through a mechanical process, but of course people do this. Imagine, if you can, a world where everything that people say could be realized, whether it was true or not. It would be chaos, wouldn't it? In the same token, for every argument that is truthful, there are an infinite number of arguments which are untruthful. The parallel is not very deep or complicated. In fact, it's very simple. In mechanics, there's one unique path that joins the path A to B, and in society, there is one unique way to discuss things, and it's called the truth. It's the parallel of going from A to B by the shortest possible route. You can have an infinite number of lies for any given truth, but the real world doesn't function on lies, even though somebody now and again tries to make it go that way. The reason our society functions is largely because it's based on the idea of the unique path of truth. Why people want to stick to the truth is a more deep question than I care to go into right now. You could give it some kind of religious basis or some kind of sociological or even economical basis, but we should all be quite clear that for an infinite number of lies, there is only one unique, truthful statement. So that's the parallel that Eddington would have drawn between the physics and the mathematics and reality. This guy is the one that some of you may recognize. He was also a person that thought along these lines, and his name is Ernst Mach. The reason why he's famous is because he put into prose, writing down in words,